Good evening, everybody. It's John here from Tutor to You, welcoming you along to another of our live streams for A-Level Geography, AQA A-Level Geography, I should say. This is the third, I think, in our series of 4 that we're delivering, and tonight we are concentrating on resource security, but it's the first of a 2-parter. So we'll start tonight. We know it's a massive, massive topic, so we're going to do part of it tonight, and then we've got another version of the same live stream next week. Now, I'm joined tonight by Fiona in the middle of the screen and Brendan on the right hand side. Good evening, both.
Good evening.
Good evening, everybody.
Welcome to you. Welcome to those of you who are joining us live. Just looking at my little clock down there, I can see loads of you have already joined us. If you're watching this on replay, of course, you can take your time over some of the questions we've got. You can pause and go through them. If you're joining us live, though, we would love to see your responses. Please do use the chat window in YouTube and tell us what you think the answer to some of our questions might be. Now, if you've not been to one of these before, we're about to use a little PowerPoint presentation to go through various bits of exam advice and some activities. You can download that PowerPoint as soon as this live stream finishes. This is being recorded, as I've already said, so of course you can watch it all over again. I think we might be ready to start. Shall I hand over to you guys?
Yes, thank you. So first in the topic, we need to understand what we mean by resource. So we have classifications of natural resources, and the main classification is whether they are stock resources or flow resources. Stock resources are non-renewable, they're going to run out, they're finite, and one example of this might be fossil fuels, whereas flow resources can be renewed in quite a short time scale, for example, wind or solar energy, but they can be considered critical flow resources and therefore become stock resources if we run out. And one example of that might be our fish stocks. Agencies, governments, and TNCs also look at stock resource evaluation to see whether or not something is a reserve or a resource. A reserve we have known concentrations available of that. It is usually a mineral. And for resources, they are viable at some point down the line, but not currently, due to perhaps some physical, economic, political, or legal, or environmental sustainability concerns that the company, agency, or government might have. So over to Brendan now for some true or false activities.
I think you might be muted, Brendan.
Thanks very much, Fiona. We're going to start off with true or false activity. So the first one is a statement. You've got to decide if this is true or false. Natural resources are evenly distributed across the globe. Take a moment to see if you think that's true or false, and if you fancy putting that in the chat, T or F, go ahead. So let's look at the answer to that one. It is false. And as with many distributions in geography, natural resources are unevenly distributed. It's very similar to what you get with other phenomena. I often use the analogy with my students to say it's a little bit if you're spreading marmalade or peanut butter on toast, you never really get it to be evenly spread or evenly distributed. So most things in geography tend to be that way. Okay, let's look at the next question. The proximity to major trade routes and shipping lanes is not a factor in the location of mining projects. Is that true or false? Let's look at it again. The proximity to major trade routes and shipping lanes is not a factor in the location of mining projects. Make your decision. Is it true or false? Got a few good ideas coming in. Let's see the correct answer. And the correct answer with this one, of course, is false. And a lot of that is to do with the fact that the materials from mining projects, even though you'd expect them, because they're very bulky, to need major trade routes to be near them, in reality, they're not necessarily near those. They have to just be where they are. And okay, next question. True or false? Protected areas and regions with high ecological sensitivity may restrict mining activities. Is that true or false? Protected areas and regions with high ecological sensitivity may restrict mining activities. What do we think? Let's see what the right answer is. Some good guesses there. It's correct. It's true. And a good example of that would be, the Arctic National Wildlife Refuge in Alaska. And you may have heard on the news that, for example, President Biden recently banned drilling to oil and gas in the ANWR. So back to Fiona.
Okay, we're going to do a brief overview of natural resource development now over time. And we say brief because we could spend a whole 35, 40 minutes on this alone. And it doesn't just include the bits that we've got on the slide. So starting at the Industrial Revolution, because humans for all of history have been accessing resources. So in prehistoric era, we've got basic tools such as flint and obsidian being used. Ancient civilizations such as the Egyptians and Greeks and Romans used metals. And in the Middle Ages, we started to see water and horse-drawn machinery, helping refine that process. And in the Renaissance, the beginnings of using gunpowder to access these resources. But if we really dig in with the Industrial Revolution, that's when things started to really change. We've got an increased demand for all types of resources because countries are industrializing, especially in the Western world. We've got steam engine powering and machine operations. They can happen on a much bigger scale. And then in the 20th century, we start to get advancements like electricity and powerful machinery revolutionize mining. So again, more progress, larger scale, and the discovery of new minerals as well, which can advance the industrial processes. After World War II, so post World War II, we have a massive increase in demand for minerals because we had to rebuild lots of cities, lots of places, and we also made massive technological advancements in the aftermath of the World War. And that's our first instance of having open pit mining and for greater efficiency as well. Then if we move on to the late 20th century, we've got environmental concerns leading to regulations and reforms in mining practices. So for example, a little bit of cross-topic synopticity here. We've got the Antarctica Agreement. So the Madrid Protocol being drawn up in 1991, not being employed to 1998, but a growing awareness of the impact that we are having. And then now we're looking at the current trends, and perhaps looking forward, we're looking at automation, so we don't need humans to do it anymore. Remote sensing, so looking at our geographical information systems technology, even more Earth elements being discovered and exploring them and their uses, and a more focus on sustainability with balancing economic development. Feel free to go back and pause the video to write any of that down if you need to. We're going to carry on with some true or false now. So thank you for those for taking part so far. Let's see if we can get a few more responses this time. So China dominates the production of rare earth elements crucial for high-tech industries. Is this true or false? Okay, let's take a look at the answer. Well done to those of you taking part. You are correct. It is true. Okay, next one. South Africa was a major player in the gold rushes. Is this true or false? Okay, let's take a look. So this is true. So some of you may not have known this before, because a lot of the focus on the gold rush is what happened in the USA. So South Africa was a big major player in that, and is still today. Well done. We can see you've got a few more people joining in now, so well done to you. Let's have a look at two more. Some parts of Southeast Asia may face water security issues related to pollution and contamination. True or false? Lots of answers coming in there. Thank you very much. You are all correct. This is true. So in general, and we're being very general here, Southeast Asia mostly has issues related to pollution and contamination rather than rainfall and physical water security, whereas in general, across many parts of Africa, we're looking at physical water security issues where there's less rainfall. And then lastly, Antarctica has been mined extensively for rich mineral deposits. So you're looking at this topic and crossover with global systems and governance here. What do you think the answer is here? Great, loads of answers coming in. So people are starting to really make these links between topics, and we can reveal that this is false. I think we've had a little error here on the slide. This is false. We have not mined Antarctica extensively. Little mistake there. Don't worry, guys. You are all correct. Antarctica has not been mined extensively for rich mineral deposits. Let's move on then to have a look at water resource development over time. And over to you, Brendan.
Thanks, Fiona. Okay, so we're looking at water resource development over time. On the slide in front of you here, you can see we've taken it right up to the 18th and 19th century, then moving to the 20th century. But before that, there was various developments of water resources. So, for example, you had in Mesopotamia, where you have countries like Iraq now, the Tigris and Euphrates were very important. Ancient Egypt had a relationship with the River Nile. A little bit further east, we had the Indus civilization, the Indus River in South Asia. We've had water management systems in ancient civilizations. All of this sort of goes back a long way. A bit more recently, but still a long time ago, we've got the Roman Empire that built a lot of water infrastructure, such as aqueducts, and they innovated with water wheels for agriculture and early forms of industry. And then we moved to the medieval period when there were various other advances. So if we go to the slide where it says Industrial Revolution, we can pick out certain key elements. Industrialization had a massive impact on water consumption, obviously. And there was the development of further infrastructure, in particular canals. And then later on, as the Industrial Revolution progressed, there was a need for massive amounts of water for steam, because people were using a lot of coal to drive industry and transportation, such as coal-fired trains. This led to pollution and degradation of water quality. This was something that was happening at a much bigger scale than ever before. It happened a little bit, but not to the scale it started to happen. Then the gradual movement of the population towards towns and cities, urbanization, increased the demand for water further, and population was growing too. And we move to the 20th century, we have expansion of water supply systems, various other technological advancements in water treatment. There's a lot of very sophisticated science goes into that. A growing awareness of environmental issues and water conservation as we go through to the middle of the last century, especially from probably the 1960s, 70s onwards. And then we get the rise towards the end of the last century of international cooperation on transboundary water resources. And in particular, we're thinking of water, the water and rivers such as the River Nile and the Danube, which go across different international borders. Okay, let's have a look at the next step. And the next step we're looking at is, hang on, should we miss the slide there? About late 20th century? There we are. So water scarcity and stress is something, these are key terms you learn about in GCSE actually, but water stress means, shortages of water in various parts of the world, sometimes even including the UK, but it's not so extreme as it would be in other areas. Climate change has started to kick in and have impacts on water resources. We still have further issues and larger issues with pollution and contamination challenges. So, for example, you have the issue of microplastics creeping into our thinking during the last 10, 15 years. Sustainable water management practices and policies have also started to happen. And this brings us to the current century where we have technological innovations in water desalination. How far that will go, we don't know, but there are various issues with that, especially to do with the waste products that are created. There are strategies for addressing water scarcity and ensuring access for everybody. Then we have to think about the role of communities and governments in sustainable water management and the potential impact of emerging global challenges on water resources. So we're just going to do one true or false question now. What do you think about this one? Is this true or false? Jot your ideas in the chat if you can. COP27 was the first conference of the parties to consider the impact of climate change on water resources as a priority. Is that true or false? Some good answers there. Well done if you got the right answer, which was true. It was surprisingly included for the first time in the final declaration of the Climate Conference of the Parties. And the text actually stated the critical role of protecting, conserving and restoring water and water-related ecosystems in delivering climate adaptation benefits and co-benefits, while ensuring social and environmental safeguards. But some water scientists believe that water can have a role in climate mitigation as well as adaptation. Two other links there, synoptic links. Okay, let's move on to look at the next key concept, which is the concept of resource frontier. So resource frontier refers to an area, sometimes it's geographically on the periphery, sometimes it's less certain than that, which is being opened up for resource extraction as older, traditional, accessible resource locations become exhausted. So an associated term you will often hear is frontier hydrocarbons when we're looking for oil or gas in places that are perhaps on the edge of viability. So these resources, natural environments with little or human development, that's often where they're found. And frequently there's a lot of conflict about that. I mentioned the ANWR earlier on. They're quite often in harsh environments. So for example, in deserts for solar energy, or mountains for hydroelectric power, wind or solar, tundra for oil, coal, gas and uranium. And sometimes they're even more complicated because they might be in international territory, could be international waters or on the margins of countries. So resource frontiers can create various problems. And obviously you've got the other examples there of the Arctic and the Antarctic. We move to now look at resource peak. So resource peak refers to the moment when the maximum rate of resource exploitation is experienced. So we talk about peak coal or peak oil or peak gas. And for many years, the peaks in these these resources have been predicted, but they've tended to not always be accurate, and the peak tends to be sort of shoved further down the road. So nowadays, a resource peak can be estimated for a given location for the global supply of that resource versus the demand for that resource. That always affects the viability of things. So the estimations of resource peak tend to be dynamic because sometimes we find new resources, sometimes we have new or more efficient technologies for extracting them, and that can move the peak to a different point. When we talk about oil, new technologies not only allow for new resources to be discovered and extracted, but it's also allowed for the development of unconventional reserves, where oil and gas is being extracted from different geological structures such as shale or rock from tar sands. And you may well have done a case study about the tar sands of Alberta in Canada. And this again delays peak oil production from earlier estimates. So it really does depend on things like supply and demand, technology, and so on as to where that peak will be. Okay, back to Fiona.
Okay, so we're going to play another game now. And before we do, I'd just like to really praise those of you that are taking part. Really well done. But not only that, those of you that are asking questions for us to clarify, and those of you that are helping others, that's where your real learning comes in. So really well done on that. So for this next slide, if we reveal it, we have a group of phrases here. There are 3 groups. I'll give you a bit of a clue after a short amount of thinking time. I won't tell you initially how many phrases are in each group, but there are 3 groups. If you could group them together, can you do so into 3 separate groups? In the chat, if you want to play along, you can just use the numbers and the letters that you'd group together, and then we'll go through the answers. So I'll give you a bit of time first to start making some ideas about how you might group these different phrases or keywords together, and then we will go through what they are and why we have grouped them those days. So well done. Those of you starting to play along, well done. So you can use, it's a bit quicker to type out the number and the letter. If you're playing along at home, you can take a minute to pause this and you can group them. You can write them out. So I'll give you another 30 seconds or so. If you need longer and you're rewatching this, you can obviously pause the video. Take as long as you need. Maybe you might start looking for pairs. I can tell you in the first group, we have 3 phrases. In the second group, we have 4 phrases. And in the last group, we have 5 phrases that will go together. Okay, you can see some attempts coming in. So I'll just give you another 10 seconds or so. Well done for playing along, even if you're not sure. Again, that's where you're really going to be earning some good knowledge because you'll have tried. Okay, let's go through this for you then. So let's reveal the first group. This might then help you come to the second grouping by yourself. So these 3 phrases, mutually assured benefits, licenses, royalties and taxation, and government value, all are to do with political sustainability within resource management and how much longevity it has when we're looking through the political gaze at the resource. So if that's become a little bit clearer, that's eliminated some for you. Can you come up with the pairs, 2 pairs, or a group of 4 for the next one? Do another 5 seconds. I can see some of you are playing along as quickly as you can. Really well done for that. So yes, we've got some good answers coming in. You can see now those of you that are playing along will start to be rewarded with your correct answers. So if we go to the next slide, We have, just like some of you have said, formal employment, 1B and 1D, standard of living together, and 3D, insurance and pensions, and also 3A as well, education with economic sustainability. So how sustainable is the resource from an economic perspective? So these will be phrases that you would use to explain that and assess the resource through this. And then last but not least, that leaves us with all 5 phrases of recycling, conservation, mitigation, the environmental impact assessment, which we're going to come to in a minute, and stewardship. So these are all phrases or words that you would use when you are talking about how sustainable a resource is environmentally. So not just thinking about sustainability now that we're A-levelers in an environmental context, but also politically and socio-economically as well. So really well done for those of you playing along there. Again, if you've paused the video and you've taken the time to run that in groups, you might make some links that perhaps we haven't made. That's great. Okay, you can justify one phrase or another in another group as long as it is well justified. So let's look at sustainable resource development then. So resource sustainability, not only ensuring future generations have access to key minerals, but also the impact on the areas and the environments from which resources are being extracted, which, as we've just seen, is social, economic, political, and environmental sustainability. So looking at the big picture now and all the stakeholders involved. To ensure continuous supply of key resources while showing regard for the sustainability of source environments, environmental impact assessments, otherwise known as EIA, are used. The EIA aims to anticipate the likely impacts of a resource extraction project on surface and groundwater, on soil, air, biota, and humans, and the impact that this assessment will have will mean that the TNC, the agency, whoever is wanting to develop this resource might have to then modify the project and minimize the negative impacts. And unfortunately, this legality does vary country to country. So some countries are able to enforce these environmental impact assessments in law. And then even if they do, it does depend on the country as well. It's very difficult to regulate. Some TNCs will comply, some won't. So it's very easy to evaluate the flaws in this plan. So well done with those of you that have paid along there. And we are back to an activity now with the data lab with Brendan.
Thank you, Fiona. Okay, we're back to have a look at some graphics now. And a typical pattern that will happen in your exams is that you will have to be challenged by some novel material, novel situations. So you'll look at some data that maybe you haven't seen before and be asked to apply your learning to it. So let's have a look at the first bit of data. So it's a map of the world. We'll talk about that in just a moment. In general, because the specification in A-level requires you to learn about cartographic and graphical skills, including GIS, you can expect that to appear in some of these what we call stimulus materials. And you might be facing, say, a 6-mark question instead of analyze the data, asking you to evaluate the style of presentation. In this case, though, we need to analyze the data, and this is really an idea of trying to describe, not necessarily explain the data. So this map of the world is using the choropleth technique, and it's showing water withdrawals per capita by country in 2015. And the units, by the way, in case you can't see them because they're a little bit small, are cubic meters of water. And there is something in the legend there for no data, countries that have no data. So in a choropleth map, and remember, the spelling of it is CHORO, it's a very commonly misspelled word. A choropleth map, the data is visualized spatially using a range of shadings or colors or both, as in this one. So choropleth maps are distinguished by showing the data in designated or agreed areas, such as divided geographical areas or regions or countries, then coloured or shaded according to the value of the data. And as I say, you can do this manually, or you can use, increasingly people are using GIS to create such maps. So we're going to give you 60 seconds to analyse the map above, And remember, it's for water withdrawals per capita by country in 2015. You have 60 seconds. And it's going to be difficult for you to jot things in the chat, but do have a bit of paper, as I'm sure you have, to jot down ideas. Remember, this is geography. You must be talking about places using geographical language, geographical terminology to locate places. And you have 20 seconds remaining. Okay, now that's just a couple of seconds left. That's not a terribly generous amount of time, so please do replay the PowerPoint later on or the video and pause it to practice what you might say. Let's look at some key ideas about this then. So we can say that the highest withdrawals are in the northern hemisphere, with North America being the standout continent. That's in particular Canada and the USA, less so for Mexico and the other countries in North America. Then we have Europe and Northern Asia and South America are also quite high in terms of withdrawals, but there's a bit more variation. Anomalies might be countries such as, if you can spot them, Guyana in South America, Mongolia in Asia, Kazakhstan in Asia, and Belarus in Europe. And there are lots of countries, as you may have noticed, with no data, which is always tricky. Because we don't really know what's going on there. And there are no countries over 2,000 and 5,000 in that range. Okay, let's have a look at another piece of data. This time it's not a map. This is a different style of presentation of data visualization. Before we look at what you've got to do, this is about freshwater use by region. So it's geographical, it's just not showing the data in a map. And it's from 1901 to 2010, so over 100 years, 110 years nearly. The units on the y-axis in this case are trillion cubic meters. So that's a lot of water, isn't it? Trillion cubic meters. And here you're being assessed on your ability to analyze a graphic rather than a cartographic piece of visualization. And the technique that's being used here is called a compound line graph. Sometimes it's called a cumulative line graph, and these are tricky to interpret, but only if you forget how to read them. So we need to remind ourselves what the acronyms on the chart mean before we move on. You can see on the right-hand side there, you've got OECD, which is the Organization for Economic Cooperation and Development. And that's a lot of countries in the world that belong to an intergovernmental organization called the OECD, founded a long time ago now, 1961, and its purpose is to stimulate progress and world trade. Then we have another group, the BRICS, B-R-I-C-S, which stands for Brazil, Russia, India, China, and South Africa. That was a kind of notional group that emerged in a documentation by an economist in the 2000s, but it's become a bit more formalized in recent years. So it's an intergovernmental organization formed in 2010, and more countries are going to be joining that in 2024. And then ROW is rest of the world, all the other countries in the world. So we're going to give you 60 seconds once again to describe analyze by describing what you can see in that compound line graph. Off you go. So bear in mind, because it's a compound line graph, you really need to look at the amount of the divisions. So where one group of countries stops, that's sort of the zero line for the next group of countries. So you have to subtract the bit below it to get the next one up, if you see what I mean. If I could point to it, I would, but I can't do that right now. So you've got 15 seconds left. To jot down any particular aspects of this that really strike you as crucial. Well done. And let's have a look. So the correct answers would include, not exclusively, but you could have written things such as overall use has increased. We can see the combination of the data has gone up by 4 times as much since the end of the World Wars. It's good to put in something like that. You're adding value to your statement by saying 4 times as much, because that shows that you've looked at the data. The BRICS have increased the most. You can see that from quite a small start, their share, if you like, has gone up the largest, the greatest amount. The OECD rate has changed. It was a steeper gradient a while ago from 1950 to 1970, but then it's kind of flattened out or plateaued, as we might say, around 1980. And there are small fluctuations. Maybe it's even starting to decrease. And of course, things like that are sometimes a function of population, but they could also be a function of greater efficiencies, which might be quite a good thing. You never know. Then the rest of the world is starting to catch up with the BRIC countries, and you can see there that that has certainly increased as well, but perhaps not quite as much as the BRICS. So thanks very much. Back to Fiona.
Well done to those of you answering in the chat there. You've got all of the correct answers amongst you, so really well done. So we're going to take a look at the factors that affect the availability, distribution and characteristics of water resources here. We are going to go quite quickly through this because you'll have your own examples, and each slide gives you an example if you don't already have one, or if your teacher's not gone through perhaps an example area where this is exemplified. So the main reason might be climate. So obviously you might have different areas with seasonal rainfall or consistent rainfall throughout the year, and then this will then mean that the storage of water is in rivers, or it might be that you have to access it through aquifers. So you're kind of having a little crossover with your water and carbon unit here. So we've used the example of the Amazon. Feel free to pause the video and write any of this down. If you don't have an example, you may have somewhere else to look at. We also have the example of geology on the next slide as a factor for the availability. So different rock types, so hard rocks and soft rocks, porous rocks, impervious rocks, they can all affect the type and availability of water and how contaminated it might be. We use the example of Flint in Michigan, USA for this. So again, if you don't have an example, feel free to pause this video and write it down. So geology would be your main one of your main factors here. And then your third factor would be that of drainage. On the next slide, there we go. So this can affect the river's flow and the formation, and whether or not it can sustain agriculture and the population around it, but also that drainage can change over time. So these are all factors that you might look at in GCSE, and I guess the A-level perspective is looking at how they interlink and how that they can change over time due to different countries' policies, but also due to physical factors like climate change and what's happening around the world, and what's impacting on that water availability, water distribution, and the characteristics. And we do need to put this into practice now, what we've studied, and we have got a practice question for you to walk us through. So imagine this is the question. So we have assess the environmental impacts of a major water supply scheme you have studied. So this is a 9 marker, and we'll come to how we conclude a 9 marker in the exam gold, because they're a little bit trickier than a 20 in that you are confined with your time and space with what to write. So let's unpick this question. So your assess means to weigh up. Your environmental impacts, this is plural, and we could look at changes resulting from a specific scheme in the local, regional, or even global environment. And a very popular scheme that many of you will have studied is the China South-North project, so called South-North because it's moving water from the south to the north of the country due to demand and industrialization in that area and the lack of water that they have. And then also looking at impacts. Could we mean positive impacts there? Are there any positive? Is it negative overall? Is our assessment, are we saying that it's unfair, or that there is a significant impact, or is there an insignificant impact? So these are all ways that you could view this question. And when you are writing this question, we might consider the following points. These could be separate paragraphs, or you could link them in. So you could look at ecological disruption here. So you're looking at aquatic ecosystems and wetlands and lakes. You could look at land subsidence and the very serious environmental issues that leads to the sinking of the land, affecting infrastructure, ecosystems, and agriculture. You could have a paragraph on sediment transport and how altered flow in source regions can affect and lead to changes in sediment transport, and therefore your geomorphology of rivers, downstream ecosystem changes. We could also look at the water table and groundwater changes. So this could be a paragraph on its own as well, and how the large-scale water transfers can lower the water table in some areas and the groundwater recharge patterns. And you could also look at the CO2 emissions from energy consumption. So pumping water from one place to another can cause really vast emissions of CO2 because it takes energy to do this. So you could look at that as a more global impact. So some of these will be on a more local scale in specific ecosystems. Some of these will be on more regional or national scale, and then some of these will be on a global scale. And there may be more that you want to consider, but these would be some of the main ones for a paragraph for you. So let's look at that exam goal with Brendan now.
Thanks, Fiona. So when it comes to your argument and conclusion, when we look at what the advice is from the examination board, the exam reports, examiners' reports, they will say things such as there's no singular approach required to respond to such questions. But they are looking for a decision on the question based on the preceding content, and that's going to be a very important element for a 9-mark question response. They go on to say it's recommended that students give a brief summary statement in relation to the question. So with these sorts of things, you need to make sure that they're not going to be too categorical. It's fine, in fact, it's quite desirable to have a nuanced response, but try not to sit on the fence because you can't think of anything else to say. I often say to my students, a good way to think of it is, what would you give your statement, one way or the other, a mark out of 10? Would you give it 6 or 7 or 8, or would it be strong 9 or even 10? That's the good way to think about the weighting of your nuance for such statements. Okay, so we're reaching the end of this session. Thank you very much for spending your time with us, and don't forget that next week we will be looking at a further session on resource security, perhaps looking in particular at energy and mineral security, resource futures, and some case studies. So thank you very, very much for your time, and we look forward to seeing you again. Not too long.
Brendan, you've taken the words right out of my mouth. Thanks, of course, to everybody who's taken part tonight. Those who've actually given us some responses in the chat window, which is always gratefully received. And those of you who are watching live and taking part by yourself, wherever you are. And, of course, hopefully you found tonight useful. If you have, do give us a thumbs up in YouTube. That always helps get our message out to as many people as possible. And, of course, please do join us next week when we continue this topic even further. So massive thank you, of course. I must go to Fiona and Brendan. Thank you both for a wonderful presentation tonight. Don't forget the PowerPoint we've been using will be available to download in literally about 5 to 10 seconds time, and do look out for the recording of this if you want to go through anything again. Until we see you again, goodbye from John here at Tutor Stu. Goodbye, everybody.
Bye.